Hi everyone, my name is Apoorv Tandon and I'm a quant and LRDI faculty at Rodha. So this video here is a continuation of our Algebra CAT 2023 video solution series, right? Before we get into the video, I just want to take a couple of minutes of yours and want to talk about few things here, right? So I constantly have been receiving, some messages on LinkedIn where people are asking me, sir, we are not a part of Rodha, but do you think this booster course is really going to help us in, given that we only have 60 days in hand? Guys, you need to understand, if you have been all by yourself till now, then you really need this course. Why? Because CAT is changing every year. If you look at CAT 2023, Algebra was on a different level. People were caught off guard because they never expected such kind of questions, where you have one question, you're applying three different concepts in that, right? So you really need that guidance. You really need a mentor for you who has some experience at his back and is gonna help you, support you and guide you in the right way. For that mentoring, for that kind of guidance, you need this booster course. I completely agree that you may be very smart, you may be very intelligent, but if you do not have the right guidance, then that is of no good, right? Suppose you're practicing, let's say, questions which are extremely difficult or which are extremely easy, which is something that CAT is never going to test you on, right? Or let's say you're doing topics which is something that is very highly unlikely to be tested in CAT, right? So you're actually wasting your time, right? So a preparation that is guided is really important, right? And I feel that it's now high time, because it's only 60 days to CAT, and if you really want to get into that one of those top B schools, you really need to start moving heaven and earth, right? There's no time to there's no way you can cut yourself some slack here, because it's really high time and you need to push yourself. And and a booster course like this is something that is going to help you reach that 99.5 plus. Just look at the number of questions we are doing. We are solving 1500 plus quant questions, we are solving 250 plus LRDI sets and 30 different sectionals, right? Now these 30 different sectionals, each sectional is gonna give you plus 4 extra sets, right? So that makes it a 370 400 sets, which is a very good number, right? If you really want to be prepared for the LRDI section, I think 400 sets is something that is gonna cover up all the varieties, and then you have 1000 VRC questions, right? So I mean, it's a package in all together, and this is something that is not gonna burn a big hole in your pocket, right? So you really need to stop cutting corners, right? And you really need to decide for yourself. Instead of texting me on LinkedIn, it's high time that you decide for yourself whether you want to get into the top B school or not, and you really want to. And if you think that this can be of great support to you, this booster course where we come not only the questions, just look at the faculties here. Ravi sir, you already know him, right? Then you look at Ayush sir, he's I haven't seen a verbal faculty like him before. He's the god of VRC, right? You have the great experience of Tarun sirs and the likes of KD sir, right? So we really feel that our experienced faculty and with good quality of questions is something that you can really push your scores in CAT. So I hope that you guys sign up for this and see you guys at the booster course. On that note, let's start with the video solutions of this particular test here, right? The very first question on his screen is a question of sequence and series. Okay, it says the value of 1 plus 1 plus 1 by 3 plus into 1 by 4, and then 1 plus 1 by 3 into 1 by 16, and so on and so forth, and it's up to infinity is alright. Now I know that infinite GP is something that is very easy, but this seems a bit challenging to me, right? So let me just try to work things out, right? If I focus on this, right? If I focus on this is 1, right? If I focus on the first terms here, right? 1 into 1 by 4 is gonna give me a 1 by 4, right? 1 into 1 by 16 is gonna give me a 1 by 4 square, right? Plus 1 into 1 by 64 is gonna give me a 1 by 4 cube. And these terms are gonna continue till infinity. So can I say I can add all these terms, right? So we know that sum of an infinite GP is always given by A upon 1 minus R, right? So here R is the common ratio, and if you can see here, the R is nothing but 1 by 4 here, right? And A is 1. So this entire sum is gonna be nothing but 1 upon 1 minus 1 by 4. That comes out to be nothing but 4 by 3, right? So I have sum of all the first terms of this series here, that is 4 by 3, right? Now let's talk about the second terms here, right? So I'm gonna get a 1 by 3 into a 1 by 4, right? I'm gonna get a 1 by 3 into 1 by 4, right? Something of this sort, right? So I can say 1 by 3 into 1 by 4 plus. Then I'm gonna get a 1 by 3 into 1 by 16, right? So 1 by 3 into 1 by 16 is same as saying 1 by 3 plus 1 by 4 square plus. I'm gonna get a 1 by 3 into 1 by 64. That is gonna give me, I can say 1 by 3. So my bad, this is not a plus here, this is a multiply sign here. It's getting multiplied, right? Plus 1 by 3 into 1 by 4 cube, and so on and so forth up to infinity. Can I take out 1 by 3 common here? And what I get here is nothing but, can I say I'll get nothing but 1 by 4? Or rather, if I take out 1 by 3 into 1 by 4 common here, not 1 by 3, let's take out 1 by 3 into 1 by 4 common. So what I'm gonna get here is nothing but, I can say 1 plus 1 by 4 plus 1 by 4 square. Why do I give myself extra calculation, right? And we have already calculated this sum here, that is 4 by 3. So can I say this is nothing but, I can say here 1 by 12 into 4 by 3. So that is what I'm gonna get from here, right? Now let's look at further terms. Let's look at the next set of terms here, right? So if you look at here now, 1 by 3 is done. 1 by 9 starts from here. So 1 by 9 into 1 by 16, 1 by 9 into 1 by 64, and so on and so forth. So if I write here 1 by 9 into 1 by 16 plus 1 by 9, 1 by 16 can be written as, I'll write it as 4 square, let's say. Okay. And 9 I will write it as 3 square. Let me just make my life easier by writing it in the form of squares. And this is 1 by 3 square into 1 by 4 cube, and so on and so forth up to infinity, right? So if I take out 1 by 3 into 4 whole square common, I'm gonna get nothing but 1 plus, I can say 1 by 4, because there's a 4 cube and I've got 4 square common. This is 4 square, so I get a 1, and the next term will be 4 square, and so on and so forth, right? Up to infinity. Now this is again 4 by 3, so this is gonna give me a 1 by 12 square into 4 by 3, right? Now if you focus on these terms that I'm gonna box in blue here, right? So this particular term here, that is 1 by 12 into 4 by 3, right? That is the sum of all the second terms, right? Then the sum of all the third terms is 1 by 12 square into 4 by 3, and the first term was 4 by 3 itself. So if I take all of them in one single line, so basically can I say I'm getting a GP, I'm getting a new GP, that is something like this. I get a 4 by 3, then I get a 1 by 12 into a 4 by 3, right? Then I get a 1 by 12 square into a 4 by 3, and so on and so forth up to infinity. Now if I take out 4 by 3 common here, so that leaves me with an infinite GP of 1 plus 1 by 12 plus 1 by 12 square up to infinity, right? And if I solve this, this is gonna be nothing but, I can say 1 upon 1 minus 1 by 12, right? So sorry, my bad. So 4 by 3 into 1 minus 1 by 12 is nothing but 1 upon 11 by 12, right? And that is gonna leave me with a 4 by 3 into 12 by 11. That is nothing but, I can say 16 by 11, right? So that is one of the ways of doing it, right? Now a lot of people would also go with finding the nth term, but I don't think it makes sense finding the nth term here, because it's an infinite GP. So why do I increase my calculation and make it cumbersome by finding the nth term? The other thing that I could have done is, right, I could have approached it in a smarter way also, right? So we have something of this sort, right? Let me just take another fresh page here. Let me talk about another way of approaching this question. So this was a question that, I feel that a lot of people would have skipped seeing so many brackets and fractions, but this is a very easy one, right? I'll just focus on the first 3 brackets, okay? First 3 terms, right? So I have 1, then I have 1 plus 1 by 3 into 1 by 4 here, right? And then I have a 1 plus 1 by 3 into 1 by 9 into a 1 by 16 here, right? Now if I focus only on the first 3 terms, right? So let's understand here. 1 plus 1 by 3 is 4 by 3, right? So I'll say 1 plus 4 by 3 into 1 by 4 plus 1 plus 1 by 3 is 4 by 3, and 4 by 3 plus 1 by 9. So 4 by 3 plus 1 by 9 into 1 by 16. So that is going to give me, this 4 and 4 is cancelled here. So 1 plus 1 by 3 is 0.33 plus 4 by 3 is basically it will come out to be nothing but I can say 12 plus 1, that is 13, right? 13 by 9 into 1 by 16, right? I hope this is correct. 9 is the LCM, so 3 3 is 9, 12 and plus 1 13, right? 13 by 9 into 16, right? And so on and so forth. Now this is 1 plus 0.33 plus 13 by 144. Now what is 13 by 144? So we know that 144 10% is 14.4, right? So this is slightly less than 10%, right? So can I say this will be nothing but approximately it will come out to be nothing but 0.09, right? 144 13 by 144 will be approximately 0.09. It is closer to 9% or something, right? So can I say if I go ahead, these numbers, the fractions that I'm gonna get, they're gonna decrease, right? If I proceed further, the fractions are always gonna decrease, so it's gonna be almost negligible by the end of the series, right? So can I say my answer should be slightly greater than this whatever sum I have here. So if I focus on the just first three terms, what is my sum here? 9 and 3 is 12, so it is coming out to be approximately 1.42. So whatever is my answer should be closer to 1.42, slightly greater than 1.42, right? Now if I go back and evaluate the options, so we know that 16 by 11 is the answer, which we have already found, right? Now let's see here. So 27 by 12 is almost more than double, right? So I can straight away rule out option number B. Option number B cannot be my answer, right? 15 by 8 is also almost double, right? So this also can be ruled out. Now what is 13 by 15, right? So if you look at 13 by 15, so 13 by 15 can be written as 1 plus 2 by 13, right? Now 2 by 13 is approximately, I would say 10% of 13 is 1.3, so 20% will be 2.6. So this is less than even 20%, that is it is less than 1.2, but I want an answer which should be greater than 1.42, right? So this is also gone. So I can say 16 by 11 should be my answer, right? And if you look at 16 by 11, this is nothing but 1 plus 5 by 11, right? And 11 half is 5.5, so this is closer to 50%, so this is closer to 0.4 something, right? So this is approximately 1.4 something, so that should be my required answer. So questions in CAT are not very difficult, right? Like I said, algebra, people in the beginning of the video, that people thought that algebra was very difficult, but it's not the case, that is not the case that algebra was very difficult. It's just that you have to be on your toes, you have to think in a smart way to crack the questions, right? I completely understand that in the exam scenario it's very difficult to think of such a smart moves. This is something that is very, you take time and it's a well planned thing. Okay, let me try it out this way. You don't have that kind of time in exam. That is why we suggest that you solve a lot of questions. When you have solved a lot of questions, it comes naturally to you. These things come naturally to a faculty. Why does it happen? Because faculties have been teaching for years and years, right? So it's very important to practice a lot of questions in quant, right? Alright, let's move to the next one here. It says let n be any natural number so that 5 to the power n minus 1 is always less than 3 to the power n plus 1. Okay, so let me first figure out this part of the question here. So I know that 5 to the power n minus 1 has to be less than 3 to the power n plus 1, right? Now if I start off with n is equal to 1 here, so n is equal to 1 is gonna give me 5 to the power 0, which is definitely less than 3 to the power 2, right? If I put n as 2 here, right, let me try different values. So if I put n as 2 here, this is gonna be 5 to the power 1, and then this is gonna become 3 cube. So this is something, let me try with a slightly higher value. What about if I try with n is equal to 4? So 5 to the power cube is nothing but 125, right? And 3 to the power 5 is gonna give me a 243. So still 5 cube is lesser than 3 to the power 5. So my condition has not been violated here. How about n to the power 5? So that is gonna leave me with a 5 to the power 4, that is 625, and that is gonna give me a 3 to the power 6 here, right? So 243 is 3 to the power 5, and 243 into 3 is almost, I can say 729, I believe, right? Yeah, 729. So that is still greater. But the moment I take n is equal to 6, so this is gonna be 5 to the power 5 and 3 to the power 7 here, right? Now if I talk about 5 to the power 5 and 3 to the power 7, so 5 to the power cube is 125, 625 into 5. So 625 into 5, that is 600 into 5 is 3000, and 5 into 25 is 125. So this value is gonna be 3125. And what about 3 to the power 7? So 729 into 3. So basically I'll have a 700 into 3, that is 2100, and 29 into 3. So 30 into 3 is 90. So 29 into 3 is 87. So that is gonna give me 2187. but 2187 is not greater than 5 to the power 5. So this is where my condition gets violated, right? So the maximum value of n that we get here is nothing but equal to 5, right? So I have a value of n that is definitely equal to 5. It can be 1, 2, 3, 4, 5, right? Now, then the least integer value of m that satisfies 3 to the power n plus 1 is always less than 2 to the power n plus m for each such n. Now, for each such n, right? Now, can I say if there's a value of m which satisfies for the largest value of n, then it automatically satisfies for the smaller value of n, right? So basically, I just need to check for n is equal to 5. If I can get a value of m which satisfies for n is equal to 5, then it is automatically gonna satisfy for n is equal to 4, 3, 2 and 1, right? So here I have 3 to the power n plus 1 should be less than 2 to the power n plus. Let's put in here n is equal to 5. So if I put n as 5 here, I'm gonna get 3 to the power 6 is less than 2 to the power 5 plus m, right? Now we know that 3 to the power 6 was 729 and I need a power of 2 which is greater than 729, right? So we know that 2 to the power 9 is 512 and 2 to the power 10 is 1024, right? So because I need it to be greater than 729, so this has to be 2 to the power 10, and if this has to be 2 to the power 10, so the value of m is supposed to be 5, only then this can become 10 here. So the value of m is nothing but, the least possible value of m is nothing but equal to 5, right? I want the least possible value of m, and anything greater than that will also always satisfy, but I wanted the least value, so the answer has to be definitely 5 here, right? Let's move to the third question here. It says let n and m be two positive integers such that they are exactly 41 integers greater than 8 to the power m and less than 8 to the power n, which can be expressed as powers of 2, and I want the smallest possible value of n plus m. Alright, now if you see here, there are exactly 41 integers between 8 to the power m and 8 to the power n, right? The very first thing that is going to strike to your mind, right? Anybody who is solving this question, the first thing that is going to strike to that person's mind is, how about I write it as 2 cube, right? How about I write this as 2 cube? Now, if I have 41 integers between these numbers, right? And can I say if I want the minimum positive value of n plus m? So m should be minimum, right? And these are positive integers, right? So positive integers basically means m can be 1. So if I put m as 1 here, then this will be 2 cube, right? So if I'm putting m as 1 here, then this is 2 cube. So the next possible integer will be 2 to the power 4, the next power of 2 possible, right? And starting from 2 to the power 4, I need to go up to some power of 2 such that there are exactly 41 integers in between, right? So if I count 41 numbers from 4, so this has to be 2 to the power 44, right? 44 minus 4 is, this is how many integers? These are exactly 41 numbers, right? 44 minus 4 is 40 plus 1 is 41. So this is 2 to the power 44. So the next possible value will be nothing but 2 to the power 45, right? And if 2 to the power 45 is 3n, right? This power is same, right? So 3n is equal to 45. So that means n should be equal to 15. If 2 to the power 45 represents 2 to the power 3n, that means 3n is 45 and n is 15. And the question is asking me the value of n plus m. So the value of n plus n is nothing but 15 plus 1, that is 16, right? Another way to think it is, if let's say you're not able to count the number of numbers, right? You want to do it with the help of, let's say, variables, alright? So if I want to do it with the help of variables, so what I would have done here is, let me say something like this, okay? So I said 2 to the power 3m is my first number, right? My second number will be 2 to the power 3m plus 1, and so on and so forth up to 2 to the power 3m plus 41. Why? Because there are exactly 41 integers between 2 to the power 3m and 2 to the power 3n. Now can I say 2 to the power 3m plus 41 is same as saying 2 to the power 3n minus 1, right? Just the number before this, isn't it? So if both are same numbers, so can I say 3m plus 41 should be equal to 3n minus 1, right? And if 3m plus 41 is equal to 3n minus 1, so from here I get that n minus m should be equal to 42 by 3, right? So that is nothing but 14. Now if n minus m is equal to 14 and the value of m is 1, so I can say n will be equal to nothing but 14 plus 1, which is equal to 15. Why? Because m is already 1, right? So we have assumed the value of m as 1, so here also we'll put the value of m as 1 itself. because I want the minimum value of n plus m, right? So on substituting this value here, we get n is equal to 15, and if n is 15 and m is 1, so the minimum possible value of n plus m is 15 plus 1, that is 16, right? So again, an easy question in CAT, right? Let's move ahead to the next one here. Now this one says the sum of all possible values of x satisfying this particular equation here, which is equal to 0. The moment I saw this question was in my slot, right? And the moment I saw this question, I knew this has to be a perfect square. There's no way this equation cannot be a perfect square, right? So I immediately started working on perfect square. So 2 to the power 4x square can be written as 2 to the power 2x whole square, right? Because 2x square into whole square. Why? Because 2x square into 2. A to the power m into a to the power m raised to power n is same as a to the power m into n, right? And 2x square into 2 is 2 to the power 4x square, right? So assuming this as my a, right? If this term is a, then this is a square, so I have a square term here, right? Similarly, if you look at this 2 to the power 2x plus 30, can I write it as 2 to the power x plus 15 square, right? Can I write it as x plus 15 square whole square, isn't it? I can write it like this, right? Now x plus 15 whole square, so if I multiply the power, I'll get the same thing, right? So let's say this term is b here and I have a b square. So if I have a square, if I have a b square, I should have a 2ab as well, right? That is how the perfect square should be made, right? So 2 into what is a? A is nothing but 2 to the power 2x square and b is nothing but 2 to the power x plus 15. Now if you add all these terms here, right, because if the base is same, the powers are added, so I'll get nothing but 2x square plus x plus 15 and plus 1. That is gonna give me nothing but I can say 2 to the power 2x square plus x plus 16. And can I say this is the same term as this term here, right? These two terms are same. So basically I have a square, I have a b square, and I have a minus 2ab. So can I say my perfect square will be nothing but I can say a, that is 2 to the power 2x square, minus b, that is 2 to the power x plus 15 whole square, and this a minus b whole square should be equal to 0. So if a minus b whole square is equal to 0, that clearly implies that a is equal to b. So 2 to the power 2x square should be equal to 2 to the power x plus 15, and if the base is same, then the powers should be equal. So I can say from here that 2x square is equal to x plus 15, which implies 2x square minus x minus 15 is equal to 0, right? And I want the sum of possible values of x. So basically I want the sum of roots of this equation, and the sum of the roots of this equation will be nothing but I can say minus of minus 1, that is minus b by a, that is this upon this, right? And which is nothing but I can say minus of minus 1 by 2 is 1 by 2. So my required answer is option number C, that is 1 by 2, right? So again, a very easy question to be solved. It was not at all difficult, right? And this was, obviously people would want to leave this particular question here, but I really feel that, such kind of questions in algebra, the good thing about algebra is your accuracy will be 100%. You get right answers if you get them, right? If you get the logic, you're obviously gonna get the right answer. There's no way you can miss out on cases or something, right? That can happen in arithmetic. You might miss out on something, but algebra is shorter thing, right? And it's less time consuming. Why? Because in arithmetic, it is generally a 4-line, 5-line question. You read it and then you decode it and then you think how to approach it, right? Algebra questions is like the moment I saw the question, I know this is a perfect square, and here I start solving it, right? So algebra is always time saving, right? And people try to run from algebra, but that shouldn't be the case, all right? Let's move to the last question here for this particular video, right? Now it says let a, b, m and n be natural numbers, alright, starting from 1, such that a is greater than 1 and b is greater than 1, perfect. If a to the power m into b to the power n is 144 to the power 145, right? So a to the power m into b to the power n, right? 144 is basically 2 to the power 4 into 3 square, right? Why? Because 16 nines as 144, so this is raised to power 145, right? Now, so from here we get that a to the power m into b to the power n, right? A to the power m into b to the power n. So 4 into 145. So 4 into 145 is gonna give me a 4 5s are 20. 2 carry over. 4 2s are 4 4s are 16, and 2 18 1 carry and 580. So this is gonna be 2 to the power 580 into 3 to the power 200 and 145 and 145. So that is gonna be a 290, right? I feel that is how it is gonna be, isn't it? 2 5 is 10, 140 and 140 is 280. So that is definitely a 3 to the power 290, right? Now what mistake a lot of people have made here is because they want the value of n minus n, the possible value, right? So people assume that this is, let's say, A and this is, let's say, B, 2 and 3, and they took it as 580 minus 290, and 580 minus 290, right? 580 minus 290 is gonna give me probably, I can say, 290, right? Which is, I think this option was 290. This was not 90 here. This is a typo here, which was one of the options, right? This option was 290. So one of the options was there as 290, and a lot of people ended up marking this particular value, right? But understand here that the question wants me to find the largest possible value. If I want the largest possible value, then my m should be as least as possible. So one thing is for sure that you can, have your, let's say, the value of, okay, so I took n as 580, right? So this should be B. I rather, wrote it the other way around. So this should be B and this should be A. Let's say B was 2 and A was 3. Let's keep B as 2 still. Let's keep B as 2, okay? Can I write this 3 to the power 290 as nothing but, can I write it like this, something in this fashion? 3 to the power 290 raised to power 1. That is also possible, right? I can write it like this, right? Now, if I write it in this particular fashion, then what happens? Can I say in that scenario, the value of A becomes 3 to the power 290? And that is completely acceptable. Why? Because it has to be a natural number greater than 1, and it is a natural number greater than 1. In that case, if you compare, so the value of m becomes now 1 because 3 to the power 290 raised to power 1. So in that case, the value of m will become nothing but 1. And if m is 1 and n is still 580, in that case, the value of n minus m will be equal to, I can say, 580 minus 1, that is 579, and that is the largest possible value of n minus m, right? So my answer should be definitely option number C and not 290. So make sure, see CAT, that is what CAT is about. CAT is gonna give you very easy questions. They'll give you a slight trick towards the end where you end up making a mistake. The very obvious answer that you get in the CAT no would definitely be there in the options, but there would be a slight catch in the question. That is how CAT is. CAT is not very difficult. It's all about the catch. If you're able to figure out those catch in the questions, then you are gonna make your way through the quant section. And same is with LRDI and VRC as well. Very small play of words in RC, very small here and there conditions in LRDI. If you get hold of them, then you are gonna crack the entire set. Just one small thing, you crack the entire set. So that is what CAT is about. Time management and thinking on your toes. You have to be keep your eyes wide open when you're solving questions in CAT. You cannot afford to make silly mistakes and miss out on these small catches, right? So with this, we come to the end of this video. We'll be continuing this series. Stay tuned for the next one. Thank you very much.